Everybody has been in the situation where they have some leftover food and want to warm it up. So they throw it in the microwave and put some time on the clock. You begin to see your food heat up and some steam starts to come off it. You hear some popping oil inside the food. So you take the food out the oven and find out that it's still ice cold. No longer are the days where you start eating your microwave food and realize that it was hot and smoky on the outside but ice cold in the middle. Introducing the microwave thermometer. Microwave ovens create cold spots because of the way the radiation is propagated throughout the oven, causing areas of destructive and constructive waves. Another cause is the absorption of heat from the layer of food, causing the inner layer to be cold. This thermometer is designed with the microwave safe materials and technology as opposed to traditional thermometer that will not give accurate readings due to the interaction of microwave radiation. This thermometer has markings going up to 400 degrees Fahrenheit. It is equipped with a target temperature marker that is adjustable. Uh, you slide the marker to the desired temperature. Um, when it is in the microwave, you know it is done because it has turned red inside the marker, giving a good visual indicator without having to open the door. This thermometer uses mineral oil, which is microwave safe and gives accurate readings. The device is enclosed by the thermoplastic PEEK or PEEK, which insulates the body and exposes the tip, preventing disruption of the reading caused by the radiation and conduction of the hot outer layer, and allowing you to know when the center is truly hot. To use the thermometer, you simply slide the marker to the desired temperature, insert the device into the food, place it in the microwave, and when the temperature marker turns red, you know your food is ready. No more having to stick your finger in or have to taste test to see whether the food is ready or not. I was able to find one similar product, but it was designed to be used after going through the microwave. It had color indicators, which is a nice design because it allows the user to know how hot the food is, but it limits the versatility of product without the temperature markings. It also seems like the product was possibly a single-use product, which is very wasteful. Materials. The liquid being used as the thermal indicator is mineral oil. This material was chosen because it is a nonpolar fluid, so it won't absorb as much microwave radiation, reducing interference. It is known to have a predictable thermal expansion, allowing for more accurate results. It has a high viscosity, which would allow it to have a fast response, which is necessary in a microwave where it heats up fast. It is also non-toxic and cost effective. The material chosen for the outer insulation is a thermoplastic called PEEK or PEEK. PEEK is a good thermal insulator, so it will prevent the thermometer from indicating a hotter temperature than the in the center actually is. It is transparent to microwaves, so it won't absorb the energy intended to heat up the food. It is also durable, food safe, easy to manufacture with injection molding, and cost effective. These are the manufacturing techniques used to produce this product. The thermometer is produced using a glass blowing process. First is the bulb formation, where the bulb is shaped at one end of the hollow glass tube. Precision is crucial to ensure uniformity and prevent leakage. Then the narrow capillary tube stem is carefully attached to the bulb. Techniques like flame working are employed to fuse the bulb and stem seamlessly. Once the glass uh, components are prepared, the bulb is filled with the liquid mineral oil, is filled with the liquid mineral oil in this case. Then the thermometer may be evacuated to create a vacuum, enhancing the accuracy and responsiveness of the liquid's movement. The thermometer is calibrated using known temperature points, uh, like freezing or boiling points of water, to ensure accuracy. The glass stem and bulb are enclosed in a protective casing to prevent breakage and contamination. Then final sealing ensures that the liquid remains contained and the device remains accurate over time. For the injection mold of the cover and slider, precision engineered molds are created to match the desired part geometry. Due to the peak's high processing temperature, molds are typically made of hardened steel. For the material preparation, peak pellets are dried to remove moisture, as moisture can degrade the polymer during processing. Um, for melting and injection, the dried peak pellets are fed into the injection mold machine, melted at temperatures between 360 and 400 degrees Celsius, and injected into the mold under high pressure. Cooling and injecting, the molten peak solidifies in the mold upon cooling. Once cooled, the part is ejected from the mold cavity. Some of the changes that I would consider implementing are making a possibly digital version of the thermometer that could integrate the microwave itself and stop the heating when it gets to desired temperature. So the thermometer will be directly connected to the microwave, where when it gets to whatever temperature you set, the microwave will just turn off and indicate the user. And then similar to the existing product I found, I would add a color changing indicator as a second reference for the user just to increase ease of use. And then if I didn't add that color changer indicator, I would add a gradient to the number indicator to give the user a better idea of the intensity of each temperature. And then thank you for watching. I hope you like the microwave thermometer, and these are the sources that I used.